Welcome to the Warsaw University of Technology. We are at the Faculty of Electrical Engineering, and now we are going to one of the labs of the Institute of Control and Industrial Electronics. Please follow me. So, here we are. There are two primary tasks that are carried out in this lab. One is building power electronics converters, and the other is the development of their corresponding control algorithms. Let's take a look at the facilities and some of the devices and prototypes that are available here. My name is Luis Martínez. My colleagues and I developed a soft-start method for a boost converter that operates in a PV system and faces rapid irradiance changes.
We perform simulations in Plex. In our schematic file, we have two parts. One is the power stage and the other corresponds to the controllers. Let's take a closer look to the PV system. We have the PV model, we have the corresponding inputs, which are the irradiance and temperature, and we can see also the passive components, the capacitor and the inductors, and a wire multiplexing block indicating two branches. Then we have the characteristic switching network of the boost converter that is finally connected to the DC boost voltage. For the control stage, we can observe that the measurements are the inputs and the corresponding outputs are the PWMs, scopes, and relays. We use a dynamic library written in C, which contains all the control algorithms. We tested the soft start method under different conditions. For example, a sudden increase in irradiance, and we can make a zoom in of the different waveforms. We also tested a sudden drop in irradiance, and we can observe the waveforms of power, voltage, currents, and the state of the converter. Finally, we confirmed that the converter is able to operate in the flexible power point tracking mode. In this test bench, we have the interleaf boost converter, which is part of a bigger system that includes a battery converter and a grid-side converter. We use a bidirectional source for the DC boost voltage and a PV simulator. With all those tools, we will finally be able to corroborate our proposal experimentally. We would like to thank to the IEEE Young Professionals and the IEEE Industrial Electronics Society as well. Thanks for your support.